Hello and welcome to the next presentation that's called Routed Mode, Static and Dynamic Routing. And please join me in welcoming my dear colleague, Wei. A round of applause, please.
Hello, everyone. Welcome to my talk about a new feature in CloudStack 4.20, routed mode, which contains two types of routing mode, static routing and dynamic routing. So, a short introduction of myself. My name is Wei. I'm Chinese. Currently, I'm based in the Netherlands and Belgium. I'm a community member since 12 years ago, and committer since 2013, and also PMC member since 2017. Currently, I'm working as a software architect at ShipBlue since 2021. I'm also a member of Kubernetes.org and OpenSDN, so you can reach me by my email or just add me on GitHub. My talk will start with the why we use routed mode and what is routed mode and how to configure static routing and dynamic routing in 4.20. And if time allows, I will give some technical details on how it is implemented. At the end, a summary and some discussion of future work. So why routed mode? Most of us know in CloudStack there are three types of networks: shared network, isolated network, and L2 network. Stephen has given a great talk yesterday about the CloudStack networking. So here I will briefly summarize the network types and their limitation from stream perspective, which are also the problems we need to solve. So the first one, IP assignment. So IP address, net mask, gateway, DHCP DNS. The second one, IP routing. So we need to reach the VM from internet, and also from the VM, we need to go outside. And third one, access control. So this is for security concerns. Yeah, so we need to manage the firewall rules for incoming and outgoing traffic. So, stream perspective and also the performance. First, shared networks, direct IP, so all VMs can be publicly accessible. The CloudStack VR is not a gateway. Where is gateway? The gateway is configured on the upstream router by the operators. So, because of this, only the root admin can create the network in CloudStack. For access control, we have security groups for shared networks in advanced zone, and also from CloudStack 4.20, the security group feature is also supported for shared networks in advanced zone, so with isolated networks. So this is a very good improvement, which I want for many years. The limitation here is that it only supports KVM. Why? Because the security group rules are applied on the KVM host by IP tables, EP tables, and IP set. So it doesn't support VMware and Zen Server, XCP, and G. Yeah. For isolated networks, VM use private gateway, private IPs, so there's no public access. For the out traffic, the CloudStack VR will act as the Source NAT gateway, and CloudStack has provided several ways to access VM from the internet. So static net, somewhere it calls destination net, load balancer, port forwarding, and VPN. For each network, there are the users can create egress rules. And for public IPs, user can create firewall rules to manage the incoming traffic. So performance set, the shared networks has the best performance. Isolated networks, because there is the virtual router in the path of the traffic, so the performance is not as good as the shared networks. So we are wondering if there are new network type or a mode which can reduce the, well, avoid the limitation of these two network types. So in summary, it uses direct IP. So IPs, VM can be publicly accessible. And of course, Source NAT is not required anymore. And also static NAT, load balancer, port forwarding, VPN are all not needed. And also it can be created by anyone. So that's what we want. So this is the limitation of shared networks. For the network access control, so we expect that there are some fail rules which can be managed for all the hypervisors. And the performance side, we expect the performance will be better than ICNet networks because the CloudStack VR will not be Source NAT, so we can avoid some cost to translate the IPs from public to private. So that's why we introduced routine mode. Some users are not familiar with how we develop a CloudStack feature. So this is an example of the process, and many CloudStack features are also developed in the similar process. In this April, Alex has raised a discussion in the developer mailing list. And we got a lot of feedback from the mailing list. So we finished the high-level design in May, and also we create some. So we create some wiki page which contains a detailed design, including the API changes, database changes, UI changes, and also the workflow. And when most work are done, we create a pull request on GitHub and ask the community to review. So, and then it's tested by our QA. Alex did the final review in August. So the feature is merged into CloudStack 4.20 in this September. So it will be released in 4.20 probably next month. Okay. What is routine mode? In 4.20, we have introduced a new concept which is named network mode. So there are two options. The first one is native mode. It's the default mode for ICNet networks. The VM is private IP, so we need a NAT address to transmit IP. So in our implementation, we use CloudStack virtual router as the Source NAT gateway. The last one is the routine mode. So where the VM use public IP and the CloudStack virtual router just use the gateway. So it's not the Source NAT gateway anymore. Actually, routine mode has already been used in CloudStack. So anyone knows which feature use routine mode? No. Actually, it's IPv6. So yeah, so IPv6, every VM uses public IPv6 address, so it's not private, and the operator has to create static routes on the upstream router. Yeah. Okay, we have two implementations: rooted isolated networks and rooted VPC. So basically, the topology of rooted networks is very similar as isolated networks. For each network, we have a virtual router which acts as a gateway of the VMs. It also provides some devices, DHCP, DNS, user data, which can also be replaced by a config drive and also firewall. The difference is the IP. So the VM uses public IP, not private IP. And also, there's no support for some services. VPC is also similar as the regular VPC, rooted VPC. So it's for each VPC, there is a VPC tier which is connected to multiple tiers, and it also provides some services. Different the isolated networks, we use network ACL to manage the firewall. Yeah. And the big difference here is public IP. We use public IP in rooted VPC. Yeah. We have two routing mode in for the rooted networks and the rooted VPC. So the first one is static routing. So that's what we currently use for IPv6. So the operators have to manually add some static rules for each network and each VPC in the upstream router. So, and the last one is dynamic routing. Then the operator need to configure the dynamic BGP in the upstream router, and then CloudStack VR will automatically create BGP peers and advise the routes towards the routers. So currently we use BGP as the dynamic routing protocol in our implementation. Okay, for the access control, we have improved the egress rules to support the routing networks, and also the firewall rule for IPv6 is still working. We have introduced a new concept, a new type of firewall for routed networks, named IPv4 routing firewall. Yeah. For routed VPC, we have improved the network ACL to support the firewall. Yeah. Okay, some use cases. First, scalable private cloud. In some large organization, they use internal IP, so the public IP is not a problem anymore. And in their environment, they use shared networks with internal IPs. But scalability is a problem, because each time when they want to deploy a new application, they have to ask the operator to create a new network. With the routed network, it's more flexible. So when user create a new application or want to scale out application with new network, it just need to create a routed network, and then the new VMs in the network can connect to all the VMs in existing network, yeah, because the VM use the IP is accessible, yeah. And if the application is not used anymore, you can just remove it. So this provides more flexibility and scalability. Some users use shared networks on VMware, but as we have, as I just said, for shared networks, the security group doesn't support VMware. So I think sometimes it's a big security issue. Yeah. So if with the routed networks, it's possible, so we can configure the IPv4, IPv6 firewall rules in routed networks, which will improve the security of the network. Yeah. For now, the third one is for now, if we want to access the VM in the cloud platform from our own office network, we have to create a remote access VPN or side-side VPN between the routers. For now, we have a new option, so we can use dynamic BGP, which we can create a BGP connection between the routers, and the VMs can just use your your office IP or internal IP, so you can bring your own IP into the cloud platform. Yeah, it's easier to set up a hybrid cloud. These are 3 use cases I can think of. I believe there are more use cases. So, next section is how to configure a routing network. So the first step, operator need to create a network offering. So we have 2 new fields. So the network mode, which has 2 modes, native mode and rooted mode. And if network mode is rooted, there are 2 options: static routing and dynamic routing. Yeah. Then the operator needs to add the IPv4 subnet, which can be configured for each zone. Then the operator can create some small IPv4 subnets, which will be used for networks. This step is optional. If there's no IPv4 subnet available, CloudStack will automatically allocate IPv4 subnet based on the CIDO size, the user input. If we want to use IPv6, then we need to configure some guest prefix, DNS, and the public IPv4, IPv6 in the zone setting. Now, when all are done, then the users can create a routing network. So different as the isolated network, the user just need to input the size of the CIDO. So for example, 28, then CloudStack will automatically get an IPv4 subnet from the database, and will automatically create a new one from network. If routing mode is static, the operator needs to add static routes in the upstream router. But if NAT is dynamic, then this step is not needed. For every network, the end user can manage the IPv4 routing firewall. Yeah, so this is an example of the network. So as we can see, CloudStack has automatically allocated the IPv4 CIDO and the IPv6 CIDO based on what we request. So the IPv4 CIDO is with /28, and the IPv6 CIDO is fixed as /64. Yeah. So on the top, there are some message here. So it asks the operator to add upstream IPv4 routes and IPv6 routes. There are 2 new tabs added to the details of the network. So IPv4 routing and the IPv6 firewall. So we have 2 for the traffic type. There are 2 options: ingress and egress. For protocol, there are 3 options: TCP, UDP, and SMP. So probably in the future we will extend to support all the protocols and protocol number, yeah, if possible. Okay. So as I just said, for static routing, the operator need to add the routes in the upstream router for IPv6 and IPv4. So our question is, can these routes be added automatically? And here goes our next section. So it's dynamic routing. Yeah. Everyone knows actually the internet is a network of autonomous system. So in short, AS. If we send a package from the source server to the destination, we need to know where is the next hop of the package. So where is the route of the transmission? So it first goes to the next hop, and next hop, and next hop. So this we call routing. So routing is actually the process of selecting a route for a packet from between the networks. I think many of us has attended the Windows session for the BGP and EVPN, so I will skip this one. I think probably many of us has more knowledge on BGP than me. So to configure a dynamic routine, there are two extra steps. The first one is, well, at first, when we create the networking, we need to select the dynamic routine as the routine mode. And then the operator needs to create BGP peers. Yeah. So for each BGP peer, there is a AS number, IPv4 address, and the IPv6 address. So this, we just need to input one of them. And the password is optional if we need to input if it exists. So now the user, the operator needs to create an AS number range for the pool, which is a pool of the AS number. And when user creates the routine network, CloudStack will automatically pick up a random AS number for the network. And because we use dynamic routines, and this step is not needed anymore. Okay, this is an example of a dynamic routine. The IPv4 subnet and the IPv6 subnet are allocated. And we also have the AS number, which is also automatically allocated to this network. So now when we create some VMs and we look at the root table in the VM and the VR, we can see there are some, these are two networks, two routine networks. We can see on the virtual machine of the first left network, it has the routes advised by protocol BGP. And this route is used to connect to the VM on the right network. And similarly, on the right, in the virtual router of the second network, it also has a route to the first network. The upstream router also has two routes, one to the first network, one to the second network. Yeah. So the routing works both from between the VM to the internet and also the VM cross networks. Yeah. So if we send a message, send a packet from this VM to another VM in another network, so it will first go to the virtual router because because of the routes inside the VM, and then so the virtual router knows where to forward the packets. So it will forward packets to the virtual router of the second network, and then finally reach the destination. Yeah. So there are more functionalities. Routine networks. It also supports static routing and dynamic routing. We also improve network ACL. It supports IPv4 and dual stack. We have also improved CloudStack Kubernetes cluster to support routine networks and routine VPC. And it's also important to mention that the routine mode is also supported by VMware with NSX integration. If you are interested, please join the talk NSX integration, which will be presented by my colleague Nicholas on strings 40 in this room. Yeah. So performance tests, many users are interested in the test results. I have also tested in our NAP. So it's a nested environment, so probably the test result is different as your environment. Yeah, I use Ubuntu 24 cloud image to deploy the VM in shared network, in isolated network, in routine network, and also as the upstream router. Yeah. I use iPerf to test the speed and it uses the default setting, default port, default duration, and I test 5 times and get the mixed value of the result. Yeah. Yeah. So that's the source of the testing, and this is the destination. So I've created several networks. As you can see, actually, the shared networks, which has the best performance, and routine networks ranks the second. So it's compared with the ICNet networks. So the outgoing traffic is around 20%, 30% more than ICNet networks. So it's not as impressive as I expected. It's probably due to because we use nested environment and also the IP, the public IP on different range. So if you are interested, please test the feature in your environment. If you have, please share your testing results, and if you have any suggestions, ideas, or bug reports, please share on GitHub. It's very welcome. Yeah. Okay, how it works, how it is implemented for the virtual router is the key component for routed networks. So we need to solve string problems. First, the virtual router need to collect to all the VMs and the public interface, public network. So we in the VR, there are 3 NICs next for the ISO-NIC networks. So we have ETH1, which is the control network, and ETH0, which is the guest network, and also ETH2, which is connected to the public upstream router. And the second one, the virtual router need to be able to forward the package, which it can be very simple, enabled by 2 system configurations. And the last one, the CloudStack virtual router need to know where is the next hop of the package. So it's implemented by the routing table. So if we look at the route table in the routing table in a CloudStack VR, it has the routes to the public, and that's the default route, and the route to the VM, to its own VM, and the last 2, which are automatically advised by BGP. So with this, CloudStack VR can do the IP routing for all the traffic. It's much simpler than the VR of the native networks. For dynamic routing, we also use FR. So FR is open source and very, very powerful software. It has the BGP implementation. It also supports many other protocols. In Cloud 4.20, the CloudStack version is 8.4.4, which is not the latest version, but it just works in our testing. On the right side is a very simple FR configuration in our VR. So there are some basic configuration which specifies the AS number of the CloudStack VR and some basic configuration. And the next section is the configuration of the neighbors, so the remote BGP server. So the AS number, the password, it supports both IPv4 and IPv6. And if there are multiple BGP peers, we can add multiple configuration for them. And the next one is the IPv4 subnet and the IPv6 subnet advised to other routers. FR has provided command 9, which VTYSH to check the state and to manage the BGP sessions. So as we can see that the IPv, we use unicast, so you can see that IPv4 unicast and IPv6 unicast both working. Yeah. So regarding the IPv4 routing firewall, we use NF tables. You know that for isolated networks and VPC, currently we use IP tables, and for the routing network we use NF tables instead. So that's the tables and the chains we created for in the VRs. Yeah. So if you face some issues, you can look for the NF tables rules and probably get some clue. Yeah. The IPv6 firewall rules are also implemented by NF tables, so it's very similar. Yeah. So for routed networks and the routed VPC, the IP tables are completely dropped. So we use NF tables for all the features in routed network and routed VPC. Yeah. I think probably in the future, we will also replace NF IP tables with NF tables for isolated networks. Yeah. Okay, summary, a new network mode, routed, and we support 2 routing modes, static routing and dynamic routing, and we also support the access control for routing networks and routed VPC. So in the future work, the first one is static routes, which has been asked by many cloud users. So it's an existing feature in CloudStack. It's not new. But currently it only supports VPC private gateway. So we will extend it to support isolated networks and VPC in both native mode and routed mode. So the next hop of the route can be a router or VM or IP in the public or guest or behind the private gateway. Yeah, so it's can provide more flexible routing policy to users. Yeah. We will work on this one in the coming weeks, so it will be coming soon. Some other works. First, FR customization. FR is a very powerful tool. So currently we support only the number of multi-hops in our configuration. So we will support more, but it depends on the feedback in the community. And redundant VR for routing networks, so we can create an internal BGP version between redundant VRs to achieve redundancy. Yeah. Routed shared networks and the internal balancer on routed and shared networks. Yeah. So many thanks to my colleague Alex for the proposal and the high-level design, and Nicolas and Paul for the AS and mode management and its implementation of routed modes in NSX, and KRM for testing. So, questions?
Thank you, Wei. Unfortunately, we don't have time for questions. And please, a round of applause for Wei.